Here we have the law of cosine. I know you see three different equations, but it's actually the same law, just written three different ways. Here we have a squared is equal to b squared plus c squared minus 2bc cosine a. Now the way I like to think of this is if I have a triangle labeled ABC, one side squared is equal to the sum of the other two sides squared minus 2 times the other two sides times cosine of the corresponding angle. Let's see what that means if I have a triangle ABC. It's not a right angle triangle. It is a triangle that has three different angles, no right angles, so it doesn't really matter which side you call A, B, and C as long as you're consistent with the labeling, which we'll go over a little bit. So if I have one side squared, then the B and the C are going to be the other two sides. And then the corresponding angle that I'm talking about, remember the way we label the angles is that it's opposite to the side. Now, if you read it that way, then the other two are actually saying the same thing. If I start off with b squared equals, the other two sides are a and c. So b squared is going to be equal to the other two sides squared, that's a squared plus c squared, minus 2 times the other two, a and c, times cosine b. Alright, and then if you read the third one, it's the same thing. If I'm starting off with c squared, it's the other two sides squared added together, minus 2 times the other two sides times cosine of the same angle that you started with. So that's the law of cosine, written three different ways. So of course, we talked about this in the laws of sine, but it is so important to know how to label the triangle that we're just going to go over it briefly again for the law of cosine. So the only thing that matters is that A is opposite from A, B is opposite from B, and C is opposite from C. It does not matter which one you call A, B, and C as long as these three things happen. Remember, all three of these angles add up to 180. How is this different from what we did before? Well, the triangles are not right angles, so the hypotenuse is not necessarily C. They are oblique, which means not right angles, and they can either be acute triangles like the one you see here, or they can be obtuse triangles where one of the angles is greater than 90. In this case, we just chose to call angle A the one that's more than 90, but it can be switched around either way you want. So here's how you apply the law of cosine. Of course, we already went over that it states that a squared is equal to b squared plus c squared minus 2bc cosine a. Or you could read it as b squared equals the other two sides, a and c squared, plus 2ac cosine b, and then also as starting off with c squared and having the other two, a squared plus b squared minus 2ab cosine c. In order to apply law of cosine, you must have either all three sides, which is SSS. As you can see here, all three sides are given. In that case, you could use law of cosines to solve for an angle. Or you have two sides with the angle in between, otherwise known as side angle side, SAS. And here you can see this example. We have side B and side C with the angle A in between that. All right, so here's an example. We're going to solve the triangle, round to the nearest degree. Of course, when we say solve the triangle, we need all sides and all angles accounted for. Now, we're starting off side, 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 so you know we're going to use law of cosine. And we have all three sides already, meaning we need to find all three angles. Now, usually in a triangle where you have to solve for everything, if you do have to use the law of cosine, you'll only have to use it once. Once you get one of those angles, you'll be able to use law of sines because you have a pair. So here we have a side, side, side situation. We can use any one of these three. It just depends on which one you want to use first. In this case, I'm going to go ahead and try and solve for angle A. So we're going to subtract the b squared and the c squared because they're adding. I'm trying to get them to the other side. And we are left with negative 2bc times the cosine A. Now we're going to divide by negative 2bc, everything. And you see that we are left with cosine A, and we have a squared minus b squared minus c squared over 2bc equals cosine A. Now a common mistake that I see a lot is when we are given the numbers, people try and do this portion first. You cannot subtract that 2bc. You have to divide it. The reason being, PEMDAS does not allow you to do that. It is being multiplied, so it's kind of hitched onto this cosine A. So you have to remove the b squared and c squared first, and then divide by the negative 2bc to get cosine A by itself. So the opposite of cosine, so we can get A by itself, is arc cosine. So you're going to arc cosine the entire thing. And this is actually pretty good to keep in your notes. On a test, you probably would be given these, but if you memorize this, it'll save you a lot of time because you don't have to solve it every time. But if you don't want to memorize it, you can do the algebra, and I like to say subtract, subtract, divide. Subtract the first one, subtract the second one, divide by the negative 2bc. So let's go ahead and put the numbers in. So of course, side A is opposite from angle A, so that's 20. Side B is opposite from angle B, so that's the 12. And side C is opposite from angle C, so that's the 28. We put this all in the calculator and we get 38 degrees. Make sure you put your calculator in degrees if you're trying to get degrees as an answer. A lot of calculators start off in radians, so you have to make sure you go into the mode and switch it to degrees. So here we already have angle A, which is 38 degrees, and you'll notice that we now have a pair. If you watch the video on laws of sine, you'll know that once you have a pair, meaning in this case we have A and A, little a and big A, you can use the law of sines, which is a little bit easier than law of cosine. So in this case, we are going to be looking for an angle. We can either look for angle B or we can look for angle C. So we're going to put the angles on top, and we're going to use angle A and side A to find angle B. So we already have side B. So here we put the numbers in order to solve for sine B. The first thing we do, multiply both sides by 12. And now that we just have sine B,